Hey guys, Mr. Bellinger here. So we're going to be talking about types of forces. We're going to be mainly focusing on friction, gravity, applied force, drag force, and elastic force. So we can go ahead and ignore the next four types of forces. But you can see that there's a lot of different types of forces. We'll be touching on magnetic force later on this year. You're going to be taking Cornell notes, and on the topic, I want you to put types of forces, um, and that's going to go on your page 29 on your science notebook, I believe. Your essential question would be, how can different types of forces change an object's motion? So you want to think about how the forces are being exerted on an object and how it's changing its motion, either making it move, making it stop, making it slow down, or go faster. By now, you should know the force is a push or a pull, as we're talking about. So in this case here, the guy is applying a force on the cart this way, and it's making it move. The first type of force we want to talk about, it's probably the one we want to deal with the most for this unit, is friction. It's a force that when two objects touch, they create a force against each other, and then it's called friction. And that force goes against the direction of the motion of the object. So, for example, if the guy is sliding downhill on a mountain, the force would be on the opposite direction, going this way. So in this case, when the guy is applying a force on the cart, friction is going in the opposite direction. It doesn't mean necessarily that the object is going to move. So if you're trying to move something that has a lot of inertia or a lot of mass, even though you apply force on it, the force of friction might be higher than your force, and you're not going to be able to move the object. So if this was a carpet, for example, and this was a heavy dresser, you would not be able to move, even though you're applying force on it. The force of friction is higher than your force, so you're not going to be able to make it move. And then think about what could affect friction. If you're sliding downhill on a mountain with snow and ice, or down a mountain that has grass, which one do you think is going to go faster? And think about friction. What causes friction? So ideally, you want to think about the smoother surfaces make the objects move faster because they have less friction. So they require less force to move forward, and they can move faster. So in this case, the grass is very bumpy, which makes it a little bit slower. There's a lot more friction. So friction is affected by how rough or smooth a surface is. So think about when you're riding a bike, for example. It's a lot easier to ride on a pavement, on the cement, on the road than on grass, because the grass is very, very, very bumpy, which makes it you need to apply more force when you're pedaling to make it move. Versus here, you require less force because there's less friction. And knowing what friction is, think about how can you create less friction. So if you rub your hands together, think about how can you make it less friction in between your hands. In this case, if you added soap, your hands would be a lot more slippery, because then the hands they're not touching directly. There's soap in between, which makes it slippery, right? How about this? If you're pushing a dresser and it's too heavy, how can you make it easier? How can you make it less friction for you? You can just maybe add a cart under it, because the rolling friction, because of the wheels, make the object not touch the ground so much, which makes it easier to move. Or if you want to try to do a slip and slide, how can you make you slide more? And that's why slip and slides work, because of water. Water makes your body and the tarp, the plastic, not touch directly, which makes it a lot easier to slide. And if you add soap, you make the water thicker, which makes it touch even less. So it makes it even more slippery. The other force we're going to talk about is gravity. Gravity is defined as a force that pulls two objects towards each other. So it's what makes us fall down on Earth, because Earth is pulling on us. Earth and the moon, they're pulling on each other. So that's why the moon orbits around the Earth. It's what keeps us on Earth instead of flying away, because right here in the middle, The gravity is pulling towards the center here, so it's pulling everyone towards the center of the Earth, which keeps us on Earth. However, if you're falling down and you have a parachute, we have a different force that keeps you going down slower, which is called drag. Okay, it's also known as water or air resistance, and that is a fluid friction. So it's a friction that acts in the opposite direction of a moving object. So if you're falling down towards Earth, the air resistance, the drag, is going to hit the walls of the parachute, and it's going to make it go slower. So think about this. I think I did this example in class. If you have the same piece of paper, one that's folded, one that's not folded, which one is going to fall faster? If you said this one, yeah, you're right, because this one, even though they have the same mass, the same weight, this one has a lot less area, less surface for the air to hold up. So this one is going to fall down straight down. This one, the air is going to catch it. It's going to catch air, which means the air resistance is going to keep up a little bit longer before it falls down. Same thing goes when you kick a soccer ball. If I kick the soccer ball from here to the right, eventually it's going to slow down on air because the wind or the air, the friction of the air resistance is going to slow it down in the opposite direction, right? So you see the wind here is making this force go left versus your force that you applied on the ball is for it to go right. So that's why it slows down the ball on the air. Same thing when you're skipping a rock. When you throw a rock from here, you apply a force and the rock wants to go this way. But every time it touches the water, the drag in the water, the fluid friction, the friction slows it down a bit every time it touches the water. So every time it's going this way, the friction goes in the opposite direction. And then finally, we have the elastic force. Elastic force is when an object returns to its original shape after being compressed. So in this case, the foam here, you can compress it down. Once you let go, it goes back to its original shape. And the same thing applies when you drop like a tennis ball on the floor. It hits the floor, and then it compresses a little bit, and then it bounces back up with the floor pushing it up again, like Newton's third law of motion. And also when your object is stretched, when you create tension. In this case, like rubber bands or a slingshot, if you pull this back, the more you pull, the more force it's going to have because you're adding more tension, you're stretching it more. But then after you let go, it releases that tension, and then it returns to its original shape, okay? So those are the forces of motions, the types of forces that we have. I want you on the summary to write down, answer the question, how different forces can change an object's motion. You may start writing that with this words over here. You can say that different forces can affect an object's motion by, and this is how you're going to show me that your knowledge, you understand, you show me that you understood this lesson. And then I'll collect your science notebooks later on.